Hi. Today the main topic is why performance in front-end engineering is big and hard. Because like if you look at the blog of like how to enhance the performance of your website, and you're able to um, like learn about those kind of re-rendering and or the JavaScript, the size of the JavaScript could give back effect on your website performance. So and there's a lot of things, and there's a lot, and most of people they focus on the React re-rendering, those kind of re-rendering and the prefetching and API calls and whatever, and so and my experience of like reading the blog related to the front end performance was it's kind of too much. It's not really kind of how do I say it? There's no concrete solution for it. So I found out that there was there was a reason for there was a reason for that why there's no concrete solution for the performance. To understand the performance, you have to understand how your website, how your user see your website. So let's first begin with the what users um, what users do when they first enter your Google browser. Your Chrome is actually the applications. It's a multi-process application, and that means that there are multiple processes in the browser application. When you first enter the Google or Chrome, you're able to see this kind of search bar, and you will see those kind of UI of like bookmark and refresh button and other things. Um, when first, let's say you are the user, when you're trying to put some kind of keyword or URL in this UI in this input bar, there's something incredible thing is gonna happen. The browser, those kind of UI in the browser, those kind of UI is also um, being executed in UI thread. The UI thread is the main thread of the browser process. So when you try to like put some kind of search query on the input, and there's like bunch of recommendation, right? So those kind of thing is handled by the UI thread. And let's say you wanna go mywebsite.com. When you're trying to put this kind of keyword in the input, um, there should be recommendation, and also when you hit enter, there should be network is gonna have to do it because your website is not like closed. You don't know your website, the IP address of it. When you first visit the website, you don't know the IP address of it, and you have to get the IP address and you send a request of the server, and you have to get response of the website. Why? Because your website is actually handled by the server, static server. Mostly we use Nginx for it. So there's a static server. It sends the core files to render your fancy website, which is called HTML, CSS, and JavaScript, and it's the server. So let's say when you hit enter, there should be networks going. You have to do some kind of the logic to find the IP address of it. And and the process to get your target server's IP address is also called DNS lookup. So DNS lookup. So actually, the target is trying to find your the IP address on your target website. The DNS lookup is kind of easy. When you first, there's a, let's just delete this part. Therefore, this is your browser, Google. And when you're trying to find mywebsite.com, the first, rather than looking at some kind of like other server, your browser will search is there's IP address of your target website. So this gonna be your key, and the value is gonna be IP address, because there's a cache storage in your browser application. After that, but if there's no cache, it goes to the DNS resolver. So DNS resolver is basically the one. It's just like phone book. When 9060 or 50, there's no kind of like in that moment, we don't really store the list of your friends' phone number on your phone, because that time it's really kind of the technology is kind of really low. So what they did was they used phone book to put some kind of the name and the name of the key and the value of the phone number of it. It's also like phone book. So it's like there's a name and there's phone number of it, and also the DNS resolver is there's your website name, your domain, and the IP address. And based on the DNS resolver, he also checks is there's your website or not. Even though if there's no IP address, you have to go to the TLD, which is top level domain system. So TLD is here. TLD is like kind of top level domain. It's kind of like system, like big server of it. And TLD is the one who checks your what is gonna be ending. Is your website is being made by .com or .net or .io or whatever stuff. If it's .com, it sends the DNS clouds, the server, which is the list, which is the one who have lists of .com. Because a lot of websites use .com, right? So there's a lot of things, a lot of website, and it goes to this cloud to check is there's appropriate your IP address or not. And it goes your other DNS cloud. If there's nothing found, it goes on the DNS cloud to find your IP address. When you found your IP address, you send back to DNS resolver and renew the cache and sends to your browser. And now browser, they found the IP address and give a request of your server. And now HTML, CSS, JavaScript is going. So those kind of logic DNS lookup is handled by the network thread. So in the browser, there's a browser process. Inside browser process, the main thread is UI thread, and there's a network thread. And I know there's more. Let's just skip it. And the network thread is ones that doing the network. Even the API calls in your website is doing the network thread is doing it. So and then when you receive the HTML, CSS, JavaScript, the network thread sends to the render process. That the HTML, CSS, JavaScript, and render process when it gets the HTML, it renders the page of it. So the process is actually isolated. So the reason it can send is using IPC, inter-process communication. So let's back again. This is kind of really the flow of what happens if you type some kind of keyword or like your domain in your browser. And if you look at the performance of it, actually before even rendering the page, you can enhance the performance. But really how is it's kind of challenging, but actually this part. You can do whatever stuff to enhance the performance. Example, your server location, if it's like close to your user location, so it's gonna be more fast. So your infra engineering has to handle about those kind of thing. And also, what if there's a JavaScript, but it doesn't really change it? Your JavaScript chunk, actually, if it doesn't change, you don't have to really renew your JavaScript and always request for every time. You don't have to redo it. Rather than you request every time, you can also do the cache thing. So this is also called the cache control, and you can put like max age, and you can put some kind of numbers up here, and based on that you can put you can make into JavaScript into cache that it doesn't really frequently revalidating. But so JavaScript, if you look at the JavaScript name in your Verso, if you're trying to deploy your website into Verso, the JavaScript name is gonna be like some kind of your JavaScript chunk name that and some kind of random numbers.js. So the reason why there's a random number is because this is also called hash. The hashing is making some kind of string into really short, but it is gonna be unique. So the reason why we put hash here, because if there's new JavaScript, we have to revalidate cache, but rather than renew the original JavaScript, we have to make a new cache because we don't wanna mess with the cache, because if your former cache is not hashed, and if you renew it, there's gonna be issues gonna happen because what you expected is original one, but if it's a new one, there's gonna be issue of it. And also, if you expect a new JavaScript chunk, but if it's not renewed, you have to think about cache invalidation. There's gonna be new issues. So we use hashing on the name. That means like so you don't have to care about those kind of the collision problem. So this is how we enhance the performance even of front-end engineering, even though before the rendering process happens. So cache control, those kind of things. We can put like CDN to narrow the server location, and we can put some kind of, it was like X max H or whatever stuff that it was like public. So private, if you set the private on the cache control, you cannot put the CDN between your user's location and your server. If you use public, you can use CDN for the cache control. So this is how you enhance the web performance in the front-end engineering before the render process happens. And also, when the render process happens, there's gonna be key thing. The common tradition of now front-end engineering and front-end industries right now is doing CSR. They use React to render everything. CSR means that client-side rendering, which also means that JavaScript renders even minimal HTML and CSS. So that means that even though we render some kind of simple page, we need to have a JavaScript to make HTML rather than we put HTML on it. So to reduce those kind of performance issue, because there's a one thread which is called main thread in your render process. In JavaScript, CSS, and HTML is being executed here. You have to shorten this and make it quicker so that your website is loading is more fast enough. So you have to reduce JavaScript chunks. So, and nowadays Next.js and other frameworks use they provide SSG and SSR to reduce those kind of problem. That SSR means that don't let your browser to execute or read the JavaScript. Let server can also handle this chunk of JavaScript, so we don't have to think about the user's environment is gonna be a problem of the website. Oh, sorry. So I mean, the SSR is the recap. The SSR means that we don't want to put so much responsibility on the user, because CSR means that let JavaScript on the user side do everything, even render HTML. SSR means that we're just gonna get like initial or some kind of chunk of JS, so we're just separating of the responsibility of it. And SSG is that it's like, since we don't have to make some kind of HTML, like we don't have to make the JavaScript to render the HTML, minimal HTML if it's not really responsive. We can just use mapping SSG for it. So the HTML, rather than JavaScript do everything, put HTML from on the first, and let JavaScript only put on the responsiveness. And to put the SSG as SSR, you can improve the performance of your website, because the main problem is that your JavaScript and HTML, your JavaScript is doing everything on the main thread. So main thread is the one who renders the page, one who doing the executions. You have to reduce those kind of the length of it or the time. So this is kind of explanation of why performance in frontend engineering is kind of vague and hard. So this is it. Have a nice day. See you next time. Bye bye.